Alright, so the purpose of this video is to talk about the next phase of exponential growth, and it's called compound interest. So the formula should look very familiar to what we looked at before, but with just one new twist. We have this value of n. We do notice that it's in two spots. It's inside the parentheses and part of your exponent, so you want to be careful to have that in both spots. So most of this stuff is the same. We've got time in years. We've got your rate as a decimal, so you convert your percentage rate to a decimal. We've got our number here. I believe previously we used the letter A. I'm going to use the letter P because most textbooks use that here. So P is your initial amount or your principal, but if you see a different letter in there, that's fine. Again, we're focused on the structure. Y is your amount after T years. Usually we're talking about money and finance here when we're dealing with compound interest. So you can think about your final amount of money. And the new aspect is N, the number of compoundings I should say per year. And what that means is we have interest added to our account. In all of the problems we've done to this point, the interest was added at the end of the year. We said the word annually. Well, most of the time the bank accounts don't work that way. They usually allow you to generate interest more frequently than that. Okay, so we have some other terms when the bank decides to give you the interest more frequently throughout the year. That's to your benefit because it keeps building exponentially on top of itself that way. So the more compoundings, the better for you. Okay, so some vocabulary we see there. Different values of n that we'll see is annually, and that's 1. And if you think about that, if I plug 1 in to this equation I just showed you here for n and here for n, that would go back to the original equation that we dealt with recently for exponential growth. Okay, so that would be no different than anything we've done so far. When we change values of n that are bigger than 1, then we start getting into numbers that are a little bit bigger and impact more substantially. Okay, I do have a little thing I need to fix here. So quarterly is actually 4. I don't know why I wrote down a 2, but it's 4. So 4 times a year they would compound your interest. Monthly obviously is 12 times a year. Weekly is 52 times a year. And then daily would be 365 times a year. And in front of any of these terms, you might see the word semi or bi, like biannually or semi-annually, bi-weekly, things like that. They may word it differently, but you might see them frequently. So semi or bi, if you see those, you just double the value of n in your problem. Okay, and you should be good to go from there. All right, finally, let's go over an example to allow us to work with this and see how this goes on your calculator. So Joe invests $1,000 at a rate of 5.2%, and it's compounded quarterly. How much does he have in his account after 10 years? Okay, so let's identify these. This is your principal, or your P. Your rate, R, in this case would be, remember we converted to a decimal, 0.052. We are doing so quarterly, so our value of n equals 4 for that. And then we want to see how much he has in his account after 10 years, so that's t equals 10. All right, so going back to my original equation, I would say that y equals your principal amount first, so $1,000, and then 1 plus your rate, 0.052 over 4. And then divided by the 4 times 10 power. Okay. Now what I would do is I would multiply these two numbers before you plug it into your calculator. So in this particular case, 4 times 10 would give you 40. And then from there, I would type the rest of this in all in one phase. That way we don't have any rounding issues. Okay. So your typical values again would be 1,000. And then 1 plus, okay? If you want to put these in parentheses to avoid the concern of errors, I would do that. So 0.052 divided by 4, and then close that set of parentheses again, and then raise it to the 40th power. Okay, you might be able to get rid of that inside set of parentheses and you wouldn't run into an issue, but on some calculators you may have a concern there. Okay, so just hit enter at that point and you'll get your rough estimate. And obviously we went around to the nearest cent here since we're talking about dollars, so $1,676.40 is your answer. Okay, now I want to make sure people know too that this TI-84, there is a free plugin this year on Google Chrome. If you want to install that, you just use your school ID and go to your Chrome extensions, and you could do that. I can show you in class. Also, when we do Desmos activities, you can type this all in at once and get the correct answer. I did enable the calculator on today's activity, so you should be able to hit the calculator button at the top of the screen and type everything in all at once. Okay, so that'll allow you to not have to work with your cell phone or other devices that make you do things step by step. Okay, so hopefully you have a better tool to work with in this case. All right, so that's compound interest, and you'll do some activities with that today. Thanks for watching.